Functions. A function f is a rule that assigns to each element x in a set A exactly one element called f of x in a set B. A function is basically a mechanism that takes some input value, which we will call x, applies some mathematical rule to it, which we call f, which stands for the function, and then it transforms the input value into f of x, which we call the output value. And this is the so-called machine diagram of a function. We can also talk about the arrow diagram of a function, where you can see that in set A over here, we have some elements. In this case, we have the numbers 1, 2, 3, and 4. And all of them are being assigned some number in another set B. So for example, the number 1 gets assigned to the number 20. The number 2 also gets assigned to the number 20. That's actually okay. The number 3 gets assigned to the number 30, and the number 4 gets assigned to 40. Now, we don't know what the mechanism is, but we can see from this diagram that each one of these numbers gets assigned these numbers. Now, we can also talk about what it means to not be a function. So in this other arrow diagram, you can see that the number 1 gets assigned to it, the number 10, which is perfectly fine. But then the number 2 gets assigned the number 20 and also gets assigned the number 30. So this is not a function because the definition says to be a function, each element x gets exactly one element assigned to it, which we call f of x. So you can't have an element over here getting assigned two different elements. So basically a function is just a mathematical rule that takes an input value, which is usually a number, and transforms it into a new number by using some kind of a mathematical rule. Normally when we talk about functions, we will see it defined by a formula or an equation. So for example, a function f is defined by the formula f of x is equal to x squared plus 4. So in part A, it says express in words how f acts on the input value x to produce the output value f of x. So what does this function actually do? Well, if I plug a number x into the function, the rule says that we are going to square that number x and then add 4. So if I had to say this in words, we are going to say square the input value, then add 4. In part B, they want us to actually evaluate f of 3, f of negative 2, and f of radical 5. So when you see something like f of 3, what you're doing is you're just replacing the number x with the number 3. So in this case, f of 3, if I put a 3 where the x is, that's going to give us 3 squared plus 4, which makes sense because we are squaring the input value, right? We're squaring 3 and then adding 4. And so this would be 9 plus 4, which is 13. For f of negative 2, same idea. We are going to square negative 2 and then add 4. Now, when you square a negative, it's very important that you remember to put parentheses around that. Negative 2 quantity squared is positive 4 and then plus 4, and this is equal to 8. And finally, f of radical 5. Again, this is going to be radical 5 quantity squared plus 4. Now, what do we get when we square a radical? Well, we should remember that the radical cancels out when you square it. So radical 5 squared is just 5, and then plus 4, and that is equal to 9. Now for part C, it says find the domain and range of f. Okay, so what is the domain? So the domain is the set of input values. So it is what you are allowed to plug into the function. And the range is the set of output values. So it is what you get when you plug all the elements of your domain into the function. So let's remind ourselves that our function is f of x is equal to x squared plus 4. What numbers are you allowed to plug in here? Well, if you think about it, you can plug in positive numbers, you can plug in negative numbers, you can plug in 0, you can plug in decimals, fractions. There are no restrictions on what you can plug in here because you can square any number and then you can add 4 to that. So your domain, in this case, is all real numbers. And in interval notation, we can write this as the set from minus infinity to infinity. Now, what is the range? Well, the range is more complicated because to understand what the range is, you have to think, what do I get when I plug in all possible values of x? And that can sometimes be difficult because there are infinitely many values that you can plug in. So we have to think more generally. When you plug in a number, whether it is positive or negative, when you square it, it becomes positive, doesn't it? Right? So the smallest that x squared can ever be is when you plug in 0, because 0 squared would be 0. And then 0 plus 4 would be 4. So if you think about it, you're never going to get a number smaller than 4 when you plug in any number x, right? If I plug in x equals 1, 1 squared is 1, plus 4 is 5. So the smallest number we're ever going to get for our y value, or our f of x value, is going to be 4, and then there is no limit to how large that number can be. So the range is going to be all real numbers greater or equal to 4. And that would be all numbers from 4 up to infinity. Now for part D, let's draw a machine diagram. So if you remember, our machine diagram says you take some number x, you're going to plug it into the machine, right? The function f, and what are you going to get out? Well, basically, we know that when you plug in x, what you get out is x squared plus 4, right? So this would be sort of the machine diagram for the function f in this case. In our next example, we are simply going to evaluate the following function at each of these numbers. So let's go ahead and get to it. So for part A, we are doing f of negative 2. To do f of negative 2, we are simply going to replace x with negative 2 everywhere you see an x, and then you have to use order of operation to complete this. So we know that we're supposed to square negative 2 before we multiply by 3. So this is going to be 3 times negative 2 squared is 4. And then plus negative 2 is the same as just subtracting 2, and then minus 5. Next, we're going to multiply. 3 times 4 is 12, and then minus 2, minus 5. And from here, we can just do the subtraction. 12 minus 2 is 10, and 10 take away 5 is 5. For the next one, f of 0. Again, we're just going to replace x with 0. And this is quite a bit easier because 0 squared is 0, and 3 times 0 is 0. So this is just 0 plus 0 minus 5. And that turns out to be negative 5. Next, let's do f of 4. So again, f of 4 is simply going to be replace x with 4. And in this case, we have 3 times 4 squared is 16, plus 4 minus 5. 3 times 16 is 48, plus 4 minus 5. 48 plus 4 is 52, and 52 minus 5 is 47. So f of 4 is equal to 47. And finally, f of 1/2. Same idea. We're going to replace x with 1/2. Now, of course, anytime you're plugging in a fraction, it's going to be a little bit more work. So what is 1/2 squared? Well, 1/2 times 1/2 is 1/4. So we're going to have 3 times 1/4, and then plus 1/2 and minus 5. Now, what is 3 times 1/4? Well, remember, when you multiply a whole number to a fraction, you can think of 3 as 3 over 1, and then it's just 3 times 1 is 3, and 1 times 4 is 4. So this is 3/4 plus 1/2 minus 5. Now, to add these together, we need to have a common denominator. So the number 1/2, if we multiply the top and bottom of that fraction by 2, that's the same as 2/4. So I have 3/4 plus 2/4 minus, and then 5 is the same as 5 over 1. And if I multiply the top and bottom by 4, that's going to give us 20 over 4. And now you see we have a common denominator, and all we have to do is add and subtract the numerators. So 3 plus 2 is 5, minus 20 is negative 15 over the common denominator, which is 4. A piecewise defined function is a function that is defined in pieces. So in the example here, a cell phone plan costs $39 a month. The plan includes 2 gigabytes of free data and charges $15 per gigabyte for any additional data used. The monthly charges are a function of the number of gigabytes. So if you use between 0 and 2 gigabytes, you are only going to pay $39. But as soon as your usage is greater than 2 gigabytes, you are going to pay $39 plus 15 multiplied by the number of gigabytes over 2. So to find that out, we just take x and subtract 2. So in this problem, how do we find the cost of using 0.5 gigabytes? So that's the first one here. So the cost of 0.5 gigabytes, 0.5 is a number between 0 and 2. So that means we're using this part of the function, and that is simply 39. Right? Okay, what is the cost of using 2 gigabytes? Well, again, if x is 2, we are still in this part of the function, because if x is equal to 2, we define the function to just be 39. So once again, this is still going to be $39. Okay? Now, what's the cost of using 4 gigabytes? Well, 4 is a number bigger than 2. So we have to plug 4 into this function. And this time there's actually something to plug in. So by definition here, it's going to be 39 plus 15 times 4 minus 2. And that will be 39 plus 15 times 2, which is 39 plus 30, which is 69, right? And all of these are in dollars. And so this phone bill would be $69. Next, let's define what it means to be the net change in a function. So if you have some function f of x, we define the net change in f of x from x equals a number a to x equals a number b to simply be f of b minus f of a. So as an example here, let f of x equal x squared. Find the net change in the value of f between, in part a here, 1 to 3, and in part B, negative 2 to positive 2. So according to the definition here for part A, the net change from 1 to 3 is simply going to be f of 3 minus f of 1. Now, f of 3 is just 3 squared, and f of 1 is just 1 squared. And so this is 9 minus 1, which is 8. And in part B, the net change from negative 2 to positive 2 is going to be f of 2 minus f of negative 2. And this will be 2 squared minus negative 2 squared. 2 squared is 4. Negative 2 squared is also 4, but we are subtracting these, and so in this case, the net change would be 0. In our next example, we want to evaluate each of the following expressions for the function that we are given here. So in part A, To find f of a, remember, all we have to do is replace x with whatever's in here. So if you replace x with a, you are essentially just changing the variable of the function, right? It's kind of like the same function, but you're just changing the x to an a. So that's not too bad. How about f of negative a? So now we're going to replace x with negative a. So that'll be 2 times negative a quantity squared plus 3 times negative a minus 1. Now, negative a squared is just a squared. So this just becomes 2a squared. But 3 times negative a is negative 3a, and then minus 1. So you'll notice that when you plug negative a into the function, it is a little bit different from the original function. Now how about f of a plus h? Well, f of a plus h, same idea. We're going to replace x with a plus h. And when I plug in a plus h for x, I need to make sure I put parentheses around it. And now let's just simplify this. This will be 2 times a plus h times a plus h plus 3 times a and 3 times h will be 3a plus 3h minus 1. Now we need to multiply this out, so we're going to FOIL here a little bit. And that is going to give us 2 times a squared plus 2ah plus h squared plus the rest. And then if I multiply by 2, we have 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. And you'll notice that there are no like terms to combine here, so this actually is our answer. Now for the last part of this problem, we want to evaluate the expression f of a plus h minus f of a all divided by h. So let's go ahead and write that down. F of a plus h minus f of a all divided by h. Well, we can save ourselves a little bit of work because f of a plus h is this expression. So we can just write that down. And then in the denominator, we just have h. But then don't forget, we also are subtracting f of a. So we are subtracting, and then what is f of a? Well, that is right here. Now, when I subtract that, I have to put parentheses because when you subtract, if you're subtracting something that has more than one term, that negative must be distributed to each one of those. So let's go ahead and do that distribution and simplify. So we're going to have 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1, and then minus 2a squared minus 3a and plus 1, and then all divided by h. Now what should happen here is you should get some cancellation. So notice that 2a squared and negative 2a squared cancel out. Also, positive 3a and negative 3a cancel out, and negative 1 and positive 1 cancel out. So what we have left over in the numerator is 4ah plus 2h squared plus 3h, and then all divided by h. Now, we can simplify because we can cancel an h, but the best way to do this is to take the h on top and factor it out. So if I pull a h out of each one of those terms on top, we have 4a plus 2h plus 3, and then divided by h. And now the h's here cancel, and our final answer is 4a plus 2h plus 3. In the next example, we have a function that represents the weight of an astronaut. So if an astronaut weighs 130 pounds on the surface of the Earth, then her weight when she is h miles above the Earth is given by the following function. So in part A, it says, what is her weight when she is 100 miles above the Earth? So what is the weight of a height of 100? which stands for 100 miles. So to get this, we just need to plug in 100 here for h. So what we have is 130 multiplied by 3,960 divided by 3,960 plus 100, quantity squared. Now I could do a little bit of this without a calculator. We have 130 times 3960 divided by 3960 plus 100 is 4060, quantity squared. Now from here, let's go ahead and plug this into a calculator to get our answer. And in this case, you can see that we get an approximate answer of 123.67. We'll round that to 0.7. And this would be pounds, right? So when she's 100 miles above Earth, her weight is only going to feel like 123.7 pounds. So now for part B, it says construct a table of values for the function w that gives her weight at heights from 0 to 500 miles. So let's go ahead and bring in that table. Now, this table comes from basically just taking all the values from 0 to 500, and I counted by 100, and plugging them into this function, just like we did for part A. And if you do that, notice that you get the following values. What do you conclude from this table? Well, you can conclude that the higher she goes, the less she weighs, right? So as the height above Earth increases, the weight of the astronaut decreases. And finally, for part C, it says find the net change in the astronaut's weight from ground level to a height of 500 miles. So what is the net change from 0 miles to 500 miles? Well, we know this is going to be W of 500 minus W of 0. Now, W of 500 is in the table here. That's just 102. Minus, and then when you plug in 0, you get her original weight, which was 130. And so this is equal to negative 28. And finally, let's talk about finding domains of functions. There are two primary things we have to consider when finding the domain of a function. We need to remember that we cannot divide by 0 and we cannot take the square root of a negative number, at least not in the real number system. So when you look at the first function here, f of x is equal to 1 divided by x squared minus x, notice that the denominator here can be factored. We can factor out an x, and we get x minus 1. This helps us see quite easily that x cannot be equal to 0, because if you plug in 0 here, you're going to get 0 in the denominator. And also, x cannot be equal to 1, right? Because if you plug in 1, 1 minus 1 is also 0. So what is the domain for this function? Well, in words, we can say the domain is all real numbers except 0 and 1. Now, typically when we write the domain for a function, we do this in interval notation. So if you look at the real number line, and here's the number 0, and here is the number 1, we're saying that we can plug in any number to the left of 0. We can plug in any number in between 0 and 1, and we can plug in any number to the right of 1. So this gives us 3 intervals for our domain. So we can plug in any number from negative infinity up to 0, not including. Union, any number from 0 to 1, again, not including. And then finally, union, any number from 1 to infinity, but again, not including 1. For the next function, g of x is equal to the square root of 9 minus x squared. We don't have to worry about dividing by 0, do we? Because there is no denominator other than 1 in this problem. So instead, we need to be concerned about not taking the square root of a negative. Now, there are a couple of ways to solve for x to figure out what the domain is, but I like to think about this just from a very common sense type of perspective. Notice that we can plug in 0, right? Because 9 minus 0 squared would be 9, and the square root of 9 would be 3. And I also want you to notice that you can plug in 3, because 3 squared would be 9, and 9 minus 9 would be 0. And you can also plug in negative 3 for the same reason. But you cannot plug in x equals 4, which would be out here, because 4 squared is 16, and 9 minus 16 would be a negative number. Likewise, over here, you cannot plug in negative 4 for the same reason. So it seems like you can plug in any number in between negative 3 and positive 3, including both of those endpoints, right? So if you just think about a number like x equals 2, 2 squared is 4, 9 take away 4 is 5, and the square root of 5 is a number. So in this case, the domain is all numbers in between negative 3 and positive 3. Now let me talk about a more mathematical way to find this answer. So we know that 9 minus x squared, which is the expression inside the radical, must be greater than or equal to 0 because we cannot take the square root of a negative number. So what I can do here is a couple of different things. I can factor the left-hand side. So if I factor the left-hand side, it's going to be 3 minus x and 3 plus x, greater than or equal to 0. And again, we know that it's equal to 0 at positive 3 and negative 3. And so all we need to do is test each one of these intervals. So here I can use x equals 0 to test. Over here I can use x equals 5. And over here, let's say I use x equals negative 4. And then you would simply plug these numbers in one at a time into here and see if it's true or false. So for example, testing x equals 5, this would give us 3 minus 5 times 3 plus 5 greater than or equal to 0. And this is negative 2 times 8 is greater than or equal to 0, which says negative 16 is greater than or equal to 0, and this, of course, is false. So x cannot be 5, and that means x cannot be any number bigger than 3. And if you tested negative 4, you would find the same conclusion. And if you test x equals 0, you would find out that it works, which means x can be any number in between and including, in this case, negative 3 and positive 3. And for our final example, we have h of t equals t divided by the square root of t plus 1. So in this case, we have both a denominator and a radical. So we just need to think about what's happening here. Well, number one, we know we cannot take the square root of a negative, but we also cannot have 0 in the bottom. So whatever's inside the radical, which in this case is t plus 1, that must be strictly positive, right? It can no longer equal 0. It has to be greater than 0. And this inequality is very simple to solve. We can just subtract 1 from both sides, and we find that the domain is all numbers t that are greater than negative 1. And so this is what that looks like on a number line, and in interval notation, we would have that domain. And that concludes this video lesson.